Alright, this will be another examples under implicit differentiation. So this is an implicit function. Okay, it's an implicit function. So how are we going to differentiate this thing, right? Then we need to evaluate. We need to find the value of dy dx when it's at point y equals to 1, right? So this question, they require to find the value of dy dx when the y is 1. Alright, so and they're given that the x is positive and y is positive, right? So of course the x must be positive as the x in the square root, and y also must be positive. This both must be positive as this is ln, right? So the function in the value inside here must be positive. So alright, let's see. At first, let's see how to differentiate this function here. The most important thing is how to differentiate the function. So again, I remind you again, as this is a logarithm function, right? Logarithm function. So before you differentiate, it is always advised to using the logarithm rule first to simplify. So 2. Then you have ln square root of x plus with ln y cubed. It will be easier because why? You have multiply, right? Ln ab. So a ln plus ln b. So before you're differentiating, you make everything easier. So square root is square root of x will be x to the power 102. So you bring down the 102, you have 1 over 2 ln x plus with 3 ln y, right? You can bring this forward and 102 here. So you expand the 2. So before you this is all simplifying, okay? We are not differentiating yet. So 2 into the equation, into the expression, into the bracket. So we have 2, you have ln x, right? 2 multiplied 102 ln x plus with 2 times 3, 6 ln y. So we have y cubed equals to ln x plus with 6 ln y. So now not starting from here, but starting from here, I start differentiating here because after simplifying, it's easier to differentiate. So differentiate y cubed implicitly. So this whole thing implicitly. So you have 3y squared dy dx. Differentiate ln x, 1 over x. Differentiate 6 ln y, right? 6. Differentiating ln y, you have 1 over y, but you add a dy dx. Done. I have already differentiate this easily. If I differentiate, start from here, is okay, but I will end up with a product rule, a more complicated case here. So I'm not going to rearrange this thing because it's asked me to find the value of dy dx, not the dy dx in the, if you rearrange, it's okay, but for me, it's, I want to save my time in finding the value of dy dx when y is 1. But the problem now is, they only given you the value of y, right? You can put in the value of y here and the value of y here, but you need the value of x as well. There are no value of x here. So how are we going to getting the value of x? So as you know that this is the equation that relate x and y, right? So I can substitute the value of y here. So when y is 1, so what is the value of x? So now the first thing I want to do will be finding the value of x before I evaluate the dy dx. So, alright, before evaluating, so I substitute the y equals to 1 into the implicit function. So 1 cubed, 2 ln square root of x, 1 cubed, right? So I substitute 1 here. So you have 1. So you have 1 equals to 2 ln square root of x. Square root of 1, square root of x and 1, you're getting square root of x. So, and this you can simplify, become 2 ln x to the power 1 over 2, 1, right? So, then you're getting the 1 over 2, getting down, 1 over 2 multiplied with 2, you have 1. So ln x, ln something equals to x. So I know that ln e is 1, right? So I know that x is, so ln e, right? As 1 is ln e. So x will be e. So I'm getting x equals to e. So means that when y is 1, x is e. Then I'm going to put this value into this equation here to getting the value of dy dx. Okay, so you are substituting the value of y equals to 1. So you have 3 1 square dy dx equals to 1 over x, and your x is exponent e power 1 plus with 6 1 over 1 dy dx, right? 1 over 1 dy dx, so easier. So then here you have 3 dy dx, here you have 1 over e plus with 6 dy dx, right? So as I'm 3 dy dx minus with 6 dy dx, you have negative 3 dy dx, right? 3 minus 6, so 1 over e. So finally, your value of dy dx will be 1 over negative 3e. So it's negative 1 over 3e. So this is the answer for this question here. So I have teach you how to differentiate this non-logarithmic function implicitly, and at the same time, what is the effective way of finding the value of dy dx, right? If given only one value here, right? You substitute here and you're getting the value of x, right? So that's the techniques for solving this type of question.